In this video, we're going to talk about Venn diagrams in more detail. So we'll call this Venn diagrams and counting. We saw the idea of Venn diagrams for two sets in our last video. Let's notice that a Venn diagram with two sets has four basic regions. So let's actually shade them in. Here's one region, second basic region is here, third basic region, and then the fourth basic region is on the outside. So let's jump into an example here. Let's say n of u is equal to 60. Well, let's remember that u is our universal set. That's the set of all elements that we care about. So we've got some set that has 60 elements in it. And from there, we've got two other sets, A and B, that we care about. So A has 18 elements, B has 22 elements, and the intersection of A and B has 15 elements. Based on that, let's draw a Venn diagram. So we'll represent our universal set with a rectangle. We're going to represent our sets A and B with circles that are overlapping. And there's just one piece of information here that leads us to a basic region, and that is this fact here. There are 15 elements in the intersection of A and B. So we've got 15 elements in here. Remember, A intersect B, that's the region that's common to the two circles. And from there, we can work our way outwards. We know that A has a total of 18 elements. So if we add up the numbers in these two regions, we're going to get 18. In other words, to get this number here, we're going 18 minus the 15 that we've already accounted for. So that tells us that there are going to be 3 elements out in this region. And in a similar way, we can get this number here. We know that B has a total of 22 elements. So if we go 22 minus 15, that gives us 7 elements over here. So B has 22 elements, 15 of those are also in A, and 7 of them are in B, but not in A. And then finally, we can get the number of elements in the outer region using the fact that the universal set has 60 elements. So that's like saying there are a total of 60 elements in this entire rectangle. So if we go 60 minus the numbers we've already accounted for, so minus 3, minus 15, minus 7, that tells us how many elements are in this outer region. So if we grab our calculator, that's going to come out to 35. And that gives us our final number. So that's now a completed Venn diagram because we understand the number of elements in each of the 4 basic regions. So quick follow-up to this diagram, we're going to ask how many elements are in A but not in B. Let's look at our diagram. The region that's in A and not in B is this region here. So the answer is 3. If you wanted to write that region in set language, you would say you're talking about the region that's in A, but, well, the but is actually interpreted as an and. So in A and not in B is A intersect B complement. So we could say n of A intersect B complement is equal to 3, or we could just say 3. So new problem, now our universal set has 120 elements in it, and we've got some information about how many elements are in A, B, and A union B. Our goal is to draw a Venn diagram. So let's start with our usual setup. We've got our universal set here, and we've got our two sets A and B, which we're going to represent as overlapping circles. Now, if we look at the information in the problem, none of it leads to a basic region. The universal set is the whole rectangle, A and B represent the entire circles, and A union B actually represents these 3 regions here. So we don't have any information about a basic region yet. But if we use the inclusion-exclusion principle, let's write that down from our last video. Number of elements in A union B is equal to number of elements in A plus number of elements in B minus the number of elements in the intersection of A and B. So let's plug in here. 90 is equal to 48 plus 52 minus the number of elements in A intersect B. 48 plus 52 gives us 100. And if we now subtract 100 from both sides, we've got negative 10 equals negative the number of elements in A intersect B. And then we can divide through by negative 1. So that's telling us there are 10 elements in A intersect B. Now we've got information about a basic region, and now we can draw our Venn diagram. So let's do it. I'm going to redraw the diagram here, and we can fill in all the details. So we've decided that there are 10 elements in the intersection of A and B, and now we can look back up at the problem and get the other information. So we said A had 48 elements, B has 52, and the entire rectangle has 120. So if A has 48 elements in total, we're going to go 48 minus the 10 that we've accounted for, gives us 38 elements over here. B has 52 elements in total. So 52 minus the 10 that we've already accounted for gives us 42 out here. And then as a final step, we're going to think about how many elements are in the universal set. So that's 120, and we're going to subtract off the 3 numbers that we've already accounted for. So minus 38, minus 10, minus 42, and that's going to give us the number in the outer region. So that leaves 30 out here, and we've now got a completed Venn diagram. So now let's turn this into a real-world problem. Out of 150 students, 60 are first year, 112 have a job, and 20 are non-first year with no job. Let's draw a Venn diagram. So let's come up with a shorthand here, shorthand name for our sets. So let's let F be the set of students who are first year, and let's let J be the set of students who have a job. So what we're trying to do is fill in a Venn diagram that looks like this. We've got all our students in this box, and we've got a set of first year students and the set of students with a job. So we want to fill in the numbers for these 4 basic regions. So let's see what we know. 150 students doesn't help us right now. That's the total number in the rectangle. 60 being first year doesn't help us because those 60 are spread across these 2 regions. And similarly, knowing that 112 have a job doesn't help us because that's again spread across 2 regions. But if we say 20 are non-first year with no job, that does lead to a basic region. So non-first year is outside the circle F, and no job is outside the circle J. So we actually want to put that 20 here. They're not first year and they don't have a job, so they're outside both circles. So we were told that 60 students were first year. We know that we have 150 students in total, so we should be able to figure out how many students are non-first year. That would be 150 minus 60, or in other words, 90 non-first year students. So if we look at where those non-first year students would be, they're outside the circle F. So they're either in here or in here. But we've already got one of those numbers. We know that we've got 20 in the outside region. So we can now say, that means this number here is going to have to be 90 minus 20. So that's going to have to be 70. So we really used 2 steps of reasoning there. First, we figured out there would be 90 non-first year students. And then we figured out that would mean there would be 70 students in this region here. So I'm going to draw a second version of this diagram just so that our reasoning doesn't get too cluttered. And let's look back at the information from the problem. So we've used the fact that 20 are non-first year with no job. We've indirectly used the fact that 60 are first year, but we may be able to use that again, we'll see. And we haven't used the fact that 112 have a job. We may be able to use the fact that there are 150 students in total. Okay, so let's move forward with this information. Let's think about 112 having a job. So that means in this circle J, there are 112 students in total. Let's go 112 minus 70 to get 42 in that central middle region there. Now, there are a couple of ways to finish this off. Probably the easiest way is to say there's 60 first-year students in total. So these 2 numbers have to add up to 60. We could go 60 minus 42 gives us 18. That would be one way to do it. Or another way to do it would be to say you've got 150 students in total. So you could go 150 minus your 3 other numbers. That would also be valid. So I'm just going to take the path of least resistance and do the easier calculation and go 60 minus 42. Now we're going to do a couple of examples with Venn diagrams with 3 sets. So if you have 3 sets A, B, C, this leads to 8 basic regions. You can count them. 1, 2, 3, 4, 5, 6, 7, and then don't forget that outer region. So there are 8 basic regions there. Let's try an example. So we've got 100 employees, and we've got a breakdown of which languages they speak. So some of them speak French, Spanish, Arabic, or combinations of those, and we want to draw a Venn diagram. So let's start off figuring out what our Venn diagram is going to look like. So we're going to have a rectangle representing all of our employees, and we're going to have 3 sets. So we usually draw the first 2 circles at the top and then a third one at the bottom here. And the sets are just going to represent the languages. So let's do F for French, S for Spanish, A for Arabic, and we're just going to write down the number of employees who speak each combination of languages. So as with our previous Venn diagram examples, the rule is that you want to start with a basic region. So for example, if someone tells you that 65 employees speak French, see, that doesn't help us right now because the circle for French actually contains 4 basic regions. So that doesn't directly lead us to filling in a number. But if we look down towards the bottom of the problem, it says 3 employees speak all 3 languages, and that's actually what's going to help us. So if you look at the region that's inside all 3 circles, it's right here in the center. We know that's 3. So that's representing a basic region. And then from there, we can work our way up. We're told that 34 employees speak French and Spanish. So French and Spanish is covered by these 2 regions here. Therefore, we should be able to get this number just by doing a subtraction. 34 speak French and Spanish. Subtract off the 3 that we've already accounted for, and that leaves us with 31. So in a similar way, we should be able to get this number and that number just by doing a subtraction. So let's do all of those within this same diagram. Okay, let's think about French and Arabic. We've got 29 employees who speak French and Arabic. So if we go 29 minus the 3 that we've already got accounted for in the middle, that's going to be 26. And then if we look at Arabic and Spanish, or Spanish and Arabic, it's 20 in total. So if we go 20 minus the 3 that we've already accounted for, we get 17. Good, so at this point we're halfway done. We've got 4 out of the 8 numbers filled in. So I think what I'm going to do is I'm going to draw a second version of the diagram, just so that we can see logically which order we're doing things in. So we were told that 65 employees speak French. And if you think about your circle for French, it actually contains 4 different regions. So we want these 4 numbers to add up to 65. Therefore, if we go 65 minus the 3 numbers that we've accounted for, that's going to give us this outer part of the circle. So 65 minus 31 minus 3 minus 26, you could grab your calculator. That comes out to 5. So we've got 5 employees in that region there. In a similar way, we're going to be able to get this number from the total number of Spanish speakers and this number by talking about Arabic speakers. So let's look up at the numbers. We said that 55 employees speak Spanish. All right, so let's go 55 minus the 3 other numbers that we've already got in the circle for Spanish. So subtract out the 31, the 3, and the 17. And that leaves us with 4 employees in this region here. Similarly for Arabic, we'll just scroll back up for a second. We've got 52 Arabic speakers at our company. So 52 minus 26 minus 3 minus 17. That's going to give us 6 people in that outer part of the Arabic circle there. And then as our final step, I think I'll just draw this one towards the bottom so that you can see the logic evolving. We know that we have 100 employees in total. So to get the outer number, we have to go 100 minus, and now we're going to subtract off the 7 other numbers that are already written down. So minus 5, minus 31, minus 4, minus 26, minus 3, minus 17, minus 6. Calculator is your friend here. So we can just plug that into the calculator and figure out how many people we're left with in that outer region. So that leaves us with 8 employees out here, and we've now got a completed Venn diagram. We can see our breakdown of our 100 employees and how they fall into the various categories of speaking various languages. So moral of the story with this Venn diagram example was to start with a basic region. And we're going to keep that in mind for our next example. So last example, each of 100 job applicants has at least one type of experience. The types of experience are presentation, coding, and international experience. We've got a breakdown, 6 pieces of information here about how many of the applicants have various types of experience, and we want to draw a Venn diagram. All right, well, we know there are going to be 3 sets in our Venn diagram because we've got these 3 categories of different types of experience. So we're going to draw 3 circles, 2 at the top and 1 at the bottom like that. And we'll just call these P, C, and I for presentation, coding, and international experience. All right, so let's see if we've got any basic regions here. Well, we've got 100 job applicants in total. Our sum of the numbers inside the rectangle is 100. But each of these job applicants has at least one type of experience. So that tells us that no one has no experience. So that tells us that the number on the outside is 0. No one is outside all 3 circles. Now we've got information about presentation experience. Okay, so that's how many people are inside the circle for P. That doesn't help us right away. Similarly, coding, international, those don't represent basic regions. And something like presentation and coding falls into 2 circles. So that covers 2 basic regions. Again, that doesn't help us directly yet. Neither does this, neither does that. So going through all of our information, it seems like we're stuck because we don't have a number right now that represents a basic region. So what we have to do is introduce a variable. We're just going to say this number in the middle is unknown. We're just going to call it X. And so we're going to solve the problem with the X in here, and we'll see that at the end of the problem, we'll be able to figure out what the value of X is and get some numbers in here. So let's look at these 3 numbers here. Specifically, let's start with presentation and coding. We know that 11 applicants have presentation and coding experience. So that means this number here is going to be 11 minus the X that we've already accounted for. Now we don't know what X is, so we're just going to call that 11 minus X. And in a similar way, we'll be able to get this number and that number. So we've got 20 applicants who have presentation and international experience. Presentation and international, these 2 regions here. So that means this number here is going to be 20 minus X. For coding and international experience, we've got 18 applicants who've got that. So this number here is going to be 18 minus X. So I'm going to draw a new diagram here, just containing this information. I'm going to make it a little bit bigger, a little bit less cluttered, and then we can finish off from there. So at this point, we've got 5 of the 8 numbers, and we just need to figure out how to get these outer numbers here. So let's think about presentation experience. We'll go back to our question for a second. We were told that 45 of these applicants have presentation experience. So what we need to do is take 45 and subtract off the 3 other numbers that we've accounted for. So we need to subtract 11 minus X, subtract X, and subtract 20 minus X. Now the bracketing is important here because we want the negative sign to distribute. So we just have to be careful with the brackets. If we do a little algebra on the side, this is 45 minus 11 plus X minus 20 plus X. So let's add our numbers together. 45 minus 11 minus 20 gives us 14. And if we add the X's together, X minus X plus an X gives us a plus X. So we're actually getting 14 plus X for this outer region here. So we're going to do this sort of algebra 3 times so that we can get a little bit of practice with that. Now let's look at the coding experience. So we were told in the question, 56 have coding experience. Okay, so we're going to go 56 minus the 3 other numbers that are already in the coding circle. So minus 11 minus x, and minus 18 minus x. And we're just being careful to bracket there. So let's take our time with this algebra and get it done right. 56 minus 11 plus x minus 18 plus x. So we're going to add the numbers together. 56 minus 11 minus 18 gives us 27. X minus x plus x gives us a plus x. So there we go. We got 27 plus x over here. And we're going to go through this fun with algebra one more time. So for international experience, scrolling back to the question, 41 of our applicants had international experience. So we'll go 41, and we need to subtract off the 3 numbers that are already in that circle I. So we'll bracket here, we'll subtract off 20 minus x, we'll subtract off x, and we'll subtract off 18 minus x. So again, if you've got brackets, you want to take a step just to expand there. So 41 minus 20 plus x minus 18 plus x. We'll do the number part. 41 minus 20 minus 18 gives us 3. And x minus x plus x gives us plus x. So 3 plus x. So we're almost done. The only issue is that we don't know what x is. So let's look back at the question and see how we can figure that out. So we've used all 6 pieces of information here. We've used the fact that each of them has at least one type of experience. That allowed us to put the 0 on the outside. But what we haven't used yet is the fact that there are 100 job applicants in total. So that's the secret to figuring out the x value. So I'm now just going to erase some of this side work to make a bit of room. And now we're going to do the last little part of the question, which is to find x. So we know that the total is 100. So 100 is equal to, now we're going to write down these 8 numbers and just add them up. So 14 plus x plus 11 minus x plus 27 plus x. You don't need brackets on here. You might find it a little bit easier to read if you do have the brackets. So I might write them in initially, but because you're adding, the brackets are not necessary. So we're just continuing to add all our numbers, the 20 minus x, the 18 minus x, the 3 plus x, and then the outer number was 0. Okay, so just count that you've got 8 things there. That's good. So on the left side, we've got 100. On the right side, let's just add up the numbers. And at this point, you might prefer to drop the brackets. Again, because you're adding everything together, the brackets are not necessary. So let's go through and look at the number part. We'll just underline things as we go. So 14 plus 11 plus 27 plus 20 plus 18 plus 3 plus 0. You could grab your calculator and figure out what that works out to. So that gives 93. And then we're going to have plus some x's. So let's underline those as we go. So we got a plus x and a minus x, a plus x and a minus x, a plus x and a minus x, and then a plus x. Okay, so overall it's a plus x. Okay, so that's how we get our x value. 100 is equal to 93 plus x. So if we subtract 93 from both sides, x is equal to 7. So we've now got our x value. In theory, right now, we've solved the problem, but it would be nice to just draw a final version of this diagram and just sub in the value 7 everywhere so that we've got our answer. So here's our Venn diagram so far. We found that x is equal to 7, so we're just going to sub x equal 7 in here, and we're going to have our final answer coming up. So let's just sub x equals 7 into each of these regions here. So working across the top, subbing in 7, we get 21. We get 11 minus 7 is 4. 27 plus 7 is 34. Our middle region was just x, so that's now becoming 7. 20 minus x gives us 13. 18 minus x gives us 11. And for the bottom part of the circle, 3 plus x is going to give us 10. And remember, we said that the outer number here was 0 because there was no one who had no experience. So that's our final answer there. We've got our breakdown of our 100 applicants and how many of them have each combination of experience. So we've seen how to build Venn diagrams for 2 and 3 sets in this video. Thanks for watching.